So our next speaker is Nickolas Means. He's a PHP developer from the olden days. Still loves PHP, but he's been doing Rails since 1.1. Somebody tried to make me contract on a Rails 1.2 app one time, and I noped out. But I hear it was fun back in the day. Yeah. But the thing that Nick is here to talk to us about is not about Rails or about PHP. A little background on Nick. His hobbies include playing with his 2 children and also programming and doing more managing than coding nowadays because he is a team lead. Yeah, I feel like you're not supposed to admit that when you're a team lead, though. Like, all management still pretends that they just code full time, man. It's amazing. I just keep typing, right? Spreadsheets don't count as code. That's not the same.
Excel macros? No?
He also pairs 100% of the time. He has a lot of experience pairing. If you have any pairing questions or pairing process questions, Nick would be a really good guy. So can we get a round of applause, please, for Nick?
Thank you, sir. Good luck. Thanks. Hi, everybody. Like Jonan said, my name is Nick. Like Terrence Lee, I am from the town of Austin, but unlike Terrence, I actually am from Austin because I'm there most of the time. I work at a company called WellMatch. We build tools for healthcare pricing transparency. Like Jonan said, I pair 100% of the time remotely, so I spend literally my full day every day on a Skype call and in Tmux and Vim, and I love it. I'll warn you before I get started here, I have 303 slides, which gives me a little less than 7 seconds a slide, so we're going to be moving pretty quick, so hang with me, please. Think back to RailsConf 2014. David Heinemeier Hansson got up on stage and started a bit of a kerfuffle in the Ruby community by telling us all that TDD is dead. But if you listen closely to his talk, he had a more subtle point as well. He spent a lot of time talking about how, as software developers, we don't spend much time in the realm of computer science. We actually spend most of our time writing. He said that if we're not engineers, what are we then? We're software writers. Well, that got me to thinking, what would happen if we took that way too literally? Well, we'd have to replace our rule book, right? We couldn't use the normal best practices that we're accustomed to using to shape our code. We'd have to pick something in the writing realm. And when you're looking for a book of rules on writing, there's nothing better than Strunk and White. If you've taken a college writing course, you've definitely have at least owned a copy of this book at some point. If you had a good writing professor, you probably still own it. It was written by a Cornell professor named William Strunk back in 1918 as a handout for his students. And then it was expanded and revised by E.B. White, one of his former students, in 1959. In case you're wondering, yes, it is that E.B. White. It's been published countless numbers of times, including this gorgeous leather-bound, gold-embossed 50th anniversary edition right here in the middle. It's so important in the writing community, there's even a book about the book. So if you're looking for a book of rules on how to write good English prose, you can do little better than Strunk and White. But what does this have to do with code? Well, Ruby on Rails, I want you to meet my old friend, shippingutilities.rb. There's something peculiar I want to point out in the name of this class. Anytime you see the word utilities in the name of a class, you should think one thing. And true to form, here it is. That is 4-point text, in case you're curious. And like I said, some stats. It's 427 source lines of code. Has a Flog Score, which is a measure of relative complexity, of 561.1, which ain't shabby. It's got a Flay Score, which is a measure of duplication, of 70, and Code Climate rightly gives it a grade of F. Now, this is code that I wrote fresh out of being a PHP developer, so it's very much PHP written in Ruby. Everybody's seen this kind of code before. It's a Rails 1.1 app that I wrote as part of an e-commerce company that I was a part of that sells motorcycle apparel. I want to point one thing out to you here. 21% of the complexity of this class comes from a single method, build shipments. And what does that method look like? There it is in all its glory. That's what we're going to be tackling today, which is why it's going to take us a while, and I have to move really quickly. So what does it do? Well, when you're an e-commerce vendor, there's a number of different ways that you can source products to send to your customer. Primarily, you have items that are in your warehouse, like this jacket from vendor foo, and you have items that you drop ship from vendors, and that just means that a vendor ships it to the customer on your behalf. It never goes through your warehouse. The customer doesn't know it's coming direct from the vendor, but it saves you from having to handle it. So we've got a glove that's drop shipped also from vendor foo, and a helmet that's drop shipped from vendor bar. Well, there's several different ways we can break this up into shipments. We could put everything in its own box and send it along to the customer in 3 shipments. Or, since the first 2 items are both from vendor foo, we could have them go ahead and just drop ship the jacket for us along with the gloves. And that saves us from having to handle it in our warehouse, and it saves us paying for a shipment. Or if the customer is really cheap and they don't want to pay much shipping at all, we can order everything into our warehouse and put it all in one box and ship it to them. That's what this gobbledygook does. So how do we make it better? How do we start? Well, in a normal world, we would pick up our handy-dandy copy of Martin Fowler's Refactoring book and go to town. But we can't do that here. There's different rules today. I said in my abstract that we will take some smelly Ruby, which I have clearly provided, and we'll refactor it using only advice from Strunk and White's Elements of Style. It was only after I submitted this abstract that I realized there's actually a lie in this. We can't refactor code. Refactoring is not a thing in the world of writing. So we have to turn to Strunk and White to even find a basis to start improving this. So what should we do? Strunk and White Rule 5.5. Revising is part of writing. Few writers are so expert that they can produce what they're after on the first try. Quite often you'll discover, on examining the completed work, that there are serious flaws in the arrangement of the material, calling for transpositions. Serious flaws in the arrangement of the material, calling for transpositions. So I think we're right on target here. This is a perfect example of what happens when the first working version of code gets out to production. I mentioned that I was a PHP developer before. I didn't know what an automated software test was when I wrote this, so this mess is also untested. So we have to fix that. So what's the practical first step that we should take? What does Strunk and White say? Well, 5.3 tells us we need to work from a suitable design. Before beginning to compose something, gauge the nature and extent of the enterprise and work from a suitable design. Well, in writing, what that means is you want to structure your text in a way that the reader can approach it and read it and get through it and understand it. Well, we want to do the same thing in software. We want to take this code and package it up in a way that somebody encountering it is able to read it and make sense of it. Well, to start with, this thing is in desperate need of some isolation. We need to get it out of that utilities class. So we'll move it out of that file, and we'll build a class around it. We'll write a simple initializer that just calls build shipments, and we'll bring along this create group if necessary and insert collaborator method that build shipments needs to do its work. And the next thing we'll do is we'll write ourselves a test to see if we can even instantiate the thing. And of course we can't. We have an uninitialized constant, Rails default logger. Anybody that's been doing Rails for a while remembers when that was what you had to do to log something in Rails. It turns out we've got a lot of these. They're all trace debug statements. Some of them are even info level, which means that this garbage is leaking out into our production logs. So we'll start by deleting those, which cuts our line count down significantly, actually, but our tests still don't work. We have another uninitialized constant, item. And that brings me to my absolute favorite line in this whole mess. It may be the worst line of Ruby I've ever written. And it's a line that's so nice, I used it twice. So what is this thing doing? It's 2 nested active record queries inside a ternary predicated on an object type check. So if order line item has an item ID, then we want to trot off to the database and pull out an item. Otherwise, for reasons unknown, we assume it's a used item when we go get a used item out of the database instead. Well, this was obviously a clever hack that past me thought he needed to get this code working. And Strunk and White tells us something about clever hacks. 5.19, do not take shortcuts at the cost of clarity. Many shortcuts are self-defeating. They waste the reader's time instead of conserving it. The one truly reliable shortcut in writing is to choose words that are strong and sure-footed to carry readers on their way. So we need to get rid of those lines. We need to make them go away. And to do that, we need to understand how we're using the data that they fetch for us. So we've got 2 blocks in the code that use the item variable. And they happen to be in 2 legs of conditional, which makes it easy for us to tackle. We'll take the lines in that first block. So I'll pull them out, zoom them in a little bit where you can see them. I'll take the gross line and change it to an if-else statement, mainly so I can make the text a little bigger so you can read it. And then we'll turn the noise down just to the parts that we want to deal with, just the places where we mention item. Now the ship status symbol item lines, they look a little complicated, so we're going to skip them for now and come back to them. We'll start with the store ID line. We're checking, again, object type check. Past me apparently really loved checking object types because I did it a lot in this code. So we check to see if item is an instance of the item class, and if it is, we reach through item to product and grab the product store ID. Otherwise, we return 1. Actually, I do know why we do this. It's because used items are always a store ID of 1. But if it was another developer besides me, if I got hit by a bus, whoever followed behind me would have no clue what I was trying to communicate here. It makes no sense whatsoever. So how do we get rid of this? Well, let's go into our test. We've got an order line item double down here. I should tell you right now that I pulled this class completely out of the Rails app altogether. So we have none of our collaborating objects at all. If you want to find out how entangled your code is, this is a great way to find out, because it will tell you in a hurry just how entangled it is. So we want to teach our order line item double how to respond to this store ID message. Well, that's really simple since it's a double. In the real world, we'd have to go teach the real object how to do it as well. I'm going to skip that for now because I have a ton of slides. So we do that, and then we can go back up top and just send that message to order line item. Well, that same pattern works a couple more times. We can do it with this line as well, and we can do it with item drop shippable as well. So you're probably noticing a pattern here. I'm making the same change to multiple lines. There's a reason for that. Strunk and White Rule 219 says we should express coordinate ideas in similar form. This principle, that of parallel construction, requires that expressions similar in content and function be outwardly similar. The likeness of form enables the reader to recognize more readily the likeness of content and function. So if you can make things look the same in your code, it's easy for somebody approaching it to read it and to understand what it does, because they only have to understand the pattern one time, and they can apply it to a number of lines. So that's what we're doing here. We're walking through and applying that pattern. There is sort of a mismatch here. If you look at the symbol on the left, it's not an interrogative. And on the right, it is an interrogative or an a method or a h method, depending on what part of the country you're from. So we're going to take our order line item double, and we're going to teach it how to respond to plain drop shippable without the question mark. Go back up top, change it to order line item drop shippable. And now we get to tackle these ship status symbol lines. Well, this first line goes and asks our item what the shipping status is of a given quantity. Say we've got 1 in our warehouse, and the customer wants to buy 2. Well, in that case, we're going to have to drop ship it because we don't have enough to fulfill their order. But if they just want 1, we can ship it out of our warehouse. So we go ask for that shipping status symbol. And then there's a couple of special cases. It's either closeout in stock or from stock only in stock, which are 2 special edge cases that have nothing to do with what we're trying to accomplish here. We want to convert it to in stock. So that looks really complicated. It's really intimidating to think about how to refactor that. Well, actually, we can just apply the same pattern again. We can teach our order line item double how to respond to the ship status symbol message. Go up top, send that message to order line item, and that takes these 2 lines and gets rid of them. We don't need them at all. And so now, when we look at this block of code, you notice that something really interesting has happened. We're no longer referring to item at all. We've refactored it all the way out of this block of code, so we can go up here where we're setting the item variable and just get rid of it. We don't need that code at all anymore. So that terrible line just vanished because we taught another object in our system that actually should have the responsibility of answering these questions, how to answer them. So we don't have all that work in line here anymore. So we've cleaned that up, and it makes our test pass. But wait, it shouldn't. We still have that line down in the bottom. We're not testing the other leg of our conditional yet. So let's quickly add a test for it and get the failure that we're expecting, and go back down and refactor it out of that section down at the bottom. Well, the great thing is we've already taught order line item how to respond to all of these messages. So we'll just sub order line item in, get rid of that line there as well, and both of our tests are passing. So we're getting close to a suitable design, but we're not quite there. There's still something really weird about the way that you would work with this class. If you instantiate shipment builder, what would you expect it to hand you back? Well, idiomatic Ruby, shipment builder new, is going to hand you a shipment builder object. Not here. Because we're calling build shipments in the initializer, we hand back an array of shipments. So that's weird, unexpected behavior that's hard to track down. So we want to change the API of our class a little bit before we get deeper into refactoring it. We want to be able to call shipmentbuilder.new and then call build shipments. We're going to test drive that change. And the other thing you'll notice about this test is it's really not doing anything. It's just checking to see if we can instantiate it. So let's ask some meaningful questions to validate that we're actually doing what we expect to be doing with our class. We'll do the same thing with the other leg of the conditional, and then we get the 2 failures that we're expecting. Wrong number of arguments, 0 for 2. And that's because we're now calling build shipments with no arguments. We're expecting it to have the context from the class to answer the questions we're asking of it, and it doesn't yet. We need to give the class that context. So we're going to take order line items and consolidate and move them up the class to become adders. We're going to assign those adders in our initializer. That lets us come down to build shipments and get rid of the arguments, because it can now rely on the class attributes to do the work that it needs to do. And we no longer want to call build shipments in our initializer. So we'll delete that line, and we're passing. So now, I have to ask you to forgive me for what I'm about to do. I'm going to wave my hands, and magically we have all the tests that we need to support us in refactoring this class. I wish I had time to walk you through that entire process. All our tests are passing. If you want to know how to do this for real, if you want to get a good overview of how to write characterization tests for legacy Ruby, I cannot recommend Katrina Owen's therapeutic refactoring talk highly enough. She does a fantastic job of walking through the process of wrapping characterization tests around legacy code. So if you haven't watched it, it's well worth watching. Okay, so what do we want to do now? Let's go ask Strunk and White what our next step is. This is probably the most famous of Strunk and White's rules. 217, omit needless words. Vigorous writing is concise. A sentence should contain no unnecessary words, a paragraph no unnecessary sentences, for the same reason that a drawing should have no unnecessary lines and a machine no unnecessary parts. Well, clearly we've got some unnecessary words here, because this is as verbose as it could possibly be. And the first thing that stands out to me is this block right here. We're essentially creating a decorated line item object to give it some extra attributes that it needs for this class to do its job. But since we've refactored it, and we've got order line item answering most of these questions, just a little bit of work, and we can get rid of that block altogether. We've got this consolidatable line that we need to deal with, so we'll ask that question of order line item as well, and that doesn't affect our test at all. They're still passing. Now, you notice something interesting here. The symbols on the left that our open struct responds to are now the same as the messages we're sending to order line item. We've got this one weird line that returns the object that's underlying the decorated object. We can deal with that in a second. But since all of those messages on the left that our open struct responds to are the same as the ones on the right that our order line item responds to, we've taught order line item to respond to the duck type that this class relies on. Order line item now answers all the questions we have. So we can get rid of that code. We don't need it anymore. We can just sub in order line item. The one spot that we need to change, when we reach down and get the underlying object, is right here. We can just change that to the li variable, and our tests just work. We were able to swap in that object, and it does the job that that open struct was previously doing for us. Now, we've got this one weird spot up here where we have two variables that are equal to each other. That's just a quick rename away. We'll take the order line items adder, change it to line items, because it's more concise, and we're all about getting rid of verbosity right now. We'll get rid of that line altogether, and then we've got this one section down here that still refers to order line items. Everything else in the class just refers to line items. So we'll change that, and again, our tests just work. So now you can't see it, but take my word for it that there's nothing needless left here. Everything's doing a job. We can get rid of some verbosity, but we have to pick a different angle of attack. We have to move into the meat of the refactoring now. So let's look to Strunk and White again. Rule 213, make the paragraph the unit of composition. A subject requires division into topics, each of which should be dealt with in a paragraph. The object of treating each topic in a paragraph by itself is, of course, to aid the reader. So if our methods are paragraphs, build shipments is a very, very long paragraph still. Thankfully for us, it's actually pretty easy to break up into smaller paragraphs. There are two branches of a conditional that make up the entire body of the method. So we'll take this bottom bit, the smaller bit, and we'll break it out into its own paragraph first. And we'll call that build consolidated shipment, because I know what this is doing. And so when I extract it to a method and I call it build consolidated shipment, it puts a nice label around that block of code. It tells whoever follows behind me what that block of code's doing. So we call it up here. We'll do the same thing. Oh, we broke a test. And this is a problem that everybody, anytime you do a method extraction refactoring that you run into, you always have local variables that you have to rescope in order to make this kind of code work. Sure enough, we're calling shipments down here in the method that we've extracted, but we're declaring it up here in build shipments. And what that tells us is we need to elevate it as well to a class adder, or to an instance adder. So we'll move it up top and initialize it in our initializer, and then our tests are passing. We'll do the same thing with the top leg of the conditional. We'll take it out and make it its own paragraph. And then we'll call it up above. Our tests are still passing. So now build shipments tells a much clearer story. It's starting to look a lot better. But we've kind of done this thing where we took all the junk that was scattered on our kitchen cabinet and just shoved it in the junk drawer and shut the drawer. So now we have to deal with the mess that we've left in the junk drawer down here. And I do want to point out something before we get into refactoring this thing. Past Nick was apparently really proud of himself for having figured this out and thought that his solution was pretty clever, because magic goes here to do the consolidation. I'm thankful that I no longer consider this code magic, and how I've grown. So there's 3 blocks of functionality in here that we want to break out into separate paragraphs. This first block takes all of our line items and builds them into a hash by ship status symbol. So if we need to get, say, all the in-stock items that are in the shopping cart, we can do that from this hash. A second block, I actually left myself a helpful comment, maybe the only time I've ever done that. This block consolidates in-stock items to dropships only if we can get rid of all the in-stock items. So if we have to ship anything from our warehouse, that means that we have the expense of packing a box, and we have to pay that regardless. But if we can get our vendors to do all the work for us, that saves us money. We don't have to ship it ourselves. So we can consolidate all of those in-stock items to dropships. We want to do that, and that's what this pile of stuff does. And then finally, the third block of functionality, we take all the line items and we call our collaborator method to group them all together in appropriate shipments. So let's pull it out in paragraphs. The first one we'll call line items by symbol, or line items by sim. And that doesn't break anything. It was a clean extraction. But this is not very concrete. It's not doing the specific task we need it to do. It's building an entire hash of every item type, when in reality, most of the time, the question that we want to ask is just for a single item type. Strunk and White 2.16 tells us we want to use definite, specific, and concrete language. Prefer the specific to the general, the definite to the vague, and the concrete to the abstract. So how can we make this more concrete? Well, we can start by making it only return the kind of line items that we want, not this whole gross hash. So we've got this line items by ship status method that does just that for us. It only returns items for the ship status we want. And we can sub that in up top, and it doesn't actually make any changes to the readability of that method. We can do better than this. What if we, instead of line items by ship status with an argument of in-stock, could just ask for in-stock items? Well, that's going to read a whole lot clearer. It's going to be a whole lot more concrete what we're trying to accomplish with that call. And we can accomplish that easily. It adds a little bit of verbosity to the bottom, but it makes the method up above read a whole lot more cleanly. We'll do the same thing with dropship items. And now it's a whole lot easier to reason about what's going on up above. It reads more like Ruby. You can just read through it. And our tests still pass. All right, so now we need to tackle this block, this gross block. So let me try to unpack this a little bit for you. It's hard to unpack. The first thing we want to do is to see if we have any items that are in stock that are not consolidatable. So to do that, we count all of our in-stock items and see which ones are not consolidatable and make sure that count is less than 1, and we use it as a gatekeeper to determine if we should change all of the in-stock items' ship statuses to dropship, which is what we're doing down here. While we're staring at this line, let's clean it up a little bit. Now that we've got a handy-dandy in-stock items method, let's change this so we don't have to have a conditional. We can just ask for in-stock items and change them all to dropship. So back to this line. How does consolidatable get set? Well, let's look up above. We look to see if we have a matching drop shipment and if our line item is indeed drop shippable. As it turns out, this entire block is just a conditional to see if we should change all of our in-stock items to dropship. We can make it obvious what that's doing by extracting another paragraph, a consolidate to dropships A method. And we'll put it in line up above. And now it's much more obvious what that block of gobbledygook is doing, just because we've extracted it to a method and put a clear label on it. And our tests still pass. So what now? We've done the junk drawer thing again, where we've cleaned off the cabinet and we've left ourselves a mess down here. This line just, I don't know how in the world I came up with this line. The only thing that I know is back then when I wrote this line, I didn't know about the iterator.any method, or iterator.all method. I do now. And so we can express that much more concisely by saying instockitems.all consolidatable. And this is a point that's not from Strunk and White, but it is from writing. The Ruby standard library is our vocabulary as we write code. So the more of the Ruby standard library you know, the more expressively you can write your code. We can make the same sort of change up here. We're doing the same sort of thing where we count items and make sure that they're greater than 0. And what we're doing here is making sure that we have a dropship item that matches up with an in-stock item so that we have a dropship to pair an in-stock with. We're also iterating over this li variable, even though we're actually iterating over in-stock items. That's not very clear, so let's change that, the in-stock item, to make this more readable. And then we've got this conditional here. We have to make sure that all of our in-stock items are drop shippable, or it doesn't make any sense to walk through this at all. And so it makes sense to take this and just make a gatekeeper method out of it. Unless all of our in-stock items are drop shippable, we don't want to do the rest of the work. Consolidate to dropships is going to be false. So we'll just short circuit the method, get rid of the condition down here, and now we can take this and make it a one-liner, which makes it a little easier to figure out how to refactor from now. It's worse to read, but there's a better way that we can do this. What we want to do is get a list of all the vendor IDs of our in-stock items. We want to subtract out the vendor IDs of our dropship items. And what that tells us is if in-stock items is a subset of in-stock vendors is a subset of dropship vendors. If that set is empty, then we can consolidate to dropships. And that one line replaces all of this mumbo-jumbo down here. Much cleaner implementation. Now, I'll be honest, that comes really close to my too clever line. I had to think really hard about whether I wanted to leave this in or not. But I think it's idiomatic enough that later me will be able to figure out what it's doing, because it's really just algebra. It's not that hard. It's just set math. And all our tests still pass. So what now? We've done something unintentional here. We've actually made this consolidate to dropships method very confident. And what I mean by confident is that we can call it and trust it to do what we want it to do, regardless of the conditions. It's got all the conditionality it needs baked in to do the right thing every time. That actually lets us go up here and get rid of this condition and just call consolidate to dropships. We don't need that condition up above at all, and our tests still pass. So it's getting pretty good, but the story's still not quite clear. It's not obvious on first pass what this line is doing. I mean, we're changing the ship status of all the in-stock items to dropships. But let's move it down to a paragraph. Oh, sorry about that. There we go. Move it down to its own paragraph and put a label on it. And so now we know that we're consolidating to dropships with that line of code because it's clearly labeled. That lets us make it a one-liner up above. We're going to consolidate to dropships if our consolidate to dropships condition is true. Easy to understand. Now let's take this last little block of functionality and build shipments by ship status, move it down to the bottom, put a label on it, call it up above. And you'll notice now how clean build shipments by ship status is. It tells a very clear story. We're going to consolidate to dropships if the conditional is true, and then we're going to assign all of our items to shipments. And we've got a bunch of short, easy-to-understand methods that are supporting this. And all our tests still pass. So our class is starting to look pretty good. But if you take a squint test, you can see that there's still a couple of methods in here that are not quite at the same level of abstraction as everything else. They're indented just a little bit. So what can we do to get rid of that conditionality? Let's zoom in and take a look at them. Well, let's start by looking at build consolidated shipment and build shipment by ship status. These two methods are doing very similar jobs, but they look nothing alike each other. This is where we get back to Strunk and White's rule of expressing coordinate ideas in similar form. If we make these two methods look the same, someone who understands how one of them works will be able to understand how the other one works. The only thing that we're doing that's special here is we're forcing the line item ship status to consolidated when the consolidated flag in the class is true. So down here, we set the ship status of items, and then we assign them to shipments. Let's follow the same pattern up here. Instead of doing the direct assignment of items to shipments in the iterator, let's just change the ship status to consolidated as we're iterating over those items. And then let's use our assign items to shipments method to do the work of assigning them to shipments. And we'll extract that out to another little short method labeled consolidate to single shipment, so it's obvious what that line of functionality is doing. Now build consolidated shipment reads just as cleanly as build shipments by ship status. But if you're looking closely, there's still one glaring difference. Consolidate to dropships is conditional. Consolidate to single shipment is not. Well, we clearly don't want to do this all the time. We want to make it confident. So we need to look and see where else in our code that conditional is coming from. And as it turns out, it's up here. If the consolidate flag is true, or if the consolidate flag is false, we want to build shipments by ship status. And if it's true, we want to build a consolidated shipment. So let's move that condition down into our build consolidated shipment method to make it confident. And that lets us get rid of the conditional up here and build shipments, which is great. Let's go check our tests. Oh, actually, first, I forgot this step. I don't like the consolidate variable. It's not very concrete. This whole class is about consolidating shipments, consolidating items into shipments. So let's take that and rename it to single shipment so it's a little clearer what's going on. Now we're going to consolidate to single shipment if single shipment is true. But the problem is we have a couple failures. We're building extra shipments in a couple of spots, and it's pretty easy to see why. We're calling both of these methods and trusting them to be confident. But we're calling assign items to shipments down in both of these blocks of code. So we're actually calling assign items to shipments twice. Well, the easy fix to that is just to move it up to build shipments. And that gets our tests passing again. That's one of the hidden bonuses of expressing coordinate ideas in similar form. A lot of times you can spot duplication you wouldn't otherwise spot. So now we're here, but these aren't doing what they say they're doing. They're not building shipments anymore since they're not calling assign items to shipments. So we could take them and change their names, but I don't want to do that. I want to extract them out into a method that says what they're doing. These are actually optimizing the consolidation of items into shipments. So we'll move that back up above, but we still have these wonky method names that aren't very declarative. They don't really tell us what they're going to do. They're not building any shipments anymore. Well, as it turns out, we've made these two methods so simple, we don't really need the labels anymore. They read very cleanly. Consolidate to single shipment of single shipment. So we'll just take them in one line, inline them, and get rid of the other two methods. That lets us be definite and specific, and it gets our test passing. So let's put it all back in our class and see how it looks. You'll notice that there is a straight line down the left side of everything that we've refactored. We've gotten everything to the same level of abstraction. We have a lot of really small, really neat methods that are easy to understand that are doing this work. We still have this junk at the bottom of the class. I'd love to show you the refactor of it, but I just didn't have time to fit it in the talk. So I can show you how it turned out. What I ended up doing is taking that create group if necessary and insert method and made it a little inline utility class called shipment list that takes line items and associates them with the right shipment. There's one cool thing I'd like to show you about it, though. When we initialize this class, we hang it onto an instance attribute, and we inject our shipments array into it. And what that lets us do is assign line items to shipments, but the shipments array that our utility class has a handle on is the exact same Ruby object as the one our parent has a handle on, because we injected it. So we don't actually have to ask the utility object for anything back at all, because it's going to take our shipments array in the parent class and just do the right thing with it, so we can just directly return shipments. So here's the finished class. Here's where we ended up. A reminder, here's where we started. So how did we do? The Flog Score for the class, which again is a measure of duplication, the original one I extracted the method out to a class was 36. The refactored version is 0, so there's no duplication. The Flog Score for the class started at 180.4. That's just the two methods that we pulled out of shipping utilities. They were 180.4. Refactored version is 77.2. But now the pièce de résistance, the Flog Score for the build shipments method. It started at 120.7, and that's where it ended up. Now, I have to admit, that's a little bit of a cheat, because let's look. There's the initial implementation of build shipments, and there's the final implementation. So, of course, that's got a Flog Score of 3. There's nothing to it. But that was sort of the point of this whole exercise. This method is the entry point to our class. Somebody who's trying to understand what this class is doing is going to start by reading build shipments. Because we've built the right pieces here, they can read right down this method. Optimize consolidation, assign items to shipments, return shipments. It tells a very clear story. It has a good narrative arc. The first version is a rambling choose-your-own-adventure manifesto. And the second version is short, concise, and has a very clear narrative arc. Now, why did it work? Well, if you've been watching closely, you've already spotted most of this. Most of these rules that I found in Strunk and White really closely resemble things that we follow in our day-to-day development. 5.5, revise and rewrite. That's just refactoring. 5.3, work from a suitable design. That's Gang of 4, Pooter, blog post on top of blog post. Everything in the Ruby ecosystem as of late has been about applying good object design to our code. 519, don't take shortcuts at the cost of clarity. Well, law of Demeter is one great example of that. You don't want to reach through 6 objects to get the data that you need. You want to build the right abstraction so you have the right thing to ask that question of. 213, make the paragraph the unit of composition. That's single responsibility principle. So it all comes down to this, a quote from Martin Fowler in the introduction of his refactoring book. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. It's like Eric said. When we write code, the computer is at best a tangential consumer of that code. It's probably the strictest reader of your code because it's not going to execute something that's not syntactically valid. But you can write some really crappy syntactically valid code that nobody would ever be able to read. I mean, the stuff we started with is a great example of that. That's all valid Ruby, but it's impossible to tell what in the world it does. Good code helps you change it. Bad code fights you every step of the way. The quality of code is largely unknown until the first major attempt at changing it. I know I'm getting close on time, but I have one more point I want to make. I want to share some examples with you of some of my favorite pieces of modern writing. There's a more subtle point that I'd like to make. I want to start with a quote from Kerouac's On the Road. I'm just going to read the last 2 sentences. He didn't have a care in the world and had the largest regard for everybody. I said to myself, wham, listen to that man laugh. That's the West. Here I am in the West. I don't know if you caught it, but those last 2 sentences are run-ons. Next, I want to show you a bit of Infinite Jest by David Foster Wallace. I'm not actually going to read it. I'm just going to point out to you that that is 1 sentence. 1. He breaks every rule possible to break in a single sentence in this sentence. And then one of my favorites, Cormac McCarthy's The Road. There's this dialogue here between father and son in a post-apocalyptic Earth. And Cormac doesn't give any attribution at all. He doesn't say who's speaking in this dialogue. But the emotion he evokes is crazy. I'm just going to read the last few lines. And then, later in the darkness. Can I ask you something? Yes, of course you can. What would you do if I died? If you died, I would want to die too. So you could be with me? Yes, so I could be with you. Okay. No attribution at all there, but you know exactly who's saying those lines. You know which one is the father, which one is the son. And you probably felt some emotion well up within you as you read those lines. I mean, those are pretty heavy lines. But he's breaking every rule there is to break about writing dialogue in fiction. He's not giving any attribution. There's no quotation marks. So here's the truth. There's a quote I'd like to share from E.B. White in an essay that he wrote about the process of writing elements of style. He says, I felt uneasy posing as an expert on rhetoric when the truth is I write by ear, always with difficulty, and seldom with any exact notion of what's taking place under the hood. So the guy that wrote the book of rules that everybody follows on the English language is pretty much saying he does not follow those rules here. Now, I think the truth here is probably somewhere in the middle. I think he follows the rules more often than he thinks, but he's got them down on some intuitive level that he doesn't have to think about the rules as he follows them. And that's true in software development as well. I mean, we follow all these best practices as we write our code, and they're best practices for a reason. They can bail you out of a lot of situations and keep you from making a lot of messes. I really love Sandy Metz's rules in Pooter. But one of the things that she says as she explains them in the book is that you have to know the points that you shouldn't follow these rules. You have to learn where you shouldn't follow them. And when we're writing software, it's the same way. It's really easy to follow all the rules. Like if you follow don't repeat yourself, it's really easy to get yourself in a mess where you've built an abstraction that nobody wants to touch with a 10-foot pole. You don't repeat yourself, but the code when you repeated yourself was actually a lot clearer. Well, it's like that when we write software. You have to develop that eye for the craft. You have to develop an intuitive feel of how to write software so that you can tell a story with your code. Because when you build the right abstraction, when you tell the right story, what you're doing is reducing the cognitive load of the developer that comes behind you. You're making it easier for them to do their job because they can read your code, it tells a clear story, and they can find the exact points in your code to make the changes they want to make. So spend the time to learn to develop that intuition. Read code, do katas, do refactoring exercises. Become a craftsman. Become the developer that can express himself clearly in code and in prose. Thanks.